Here's our Chapter 10 semester final review. Here we're going to be simplifying polynomials, and sometimes we'll be adding polynomials, sometimes we'll be subtracting polynomials, and sometimes we'll be multiplying polynomials. So it's important that we look at the operation that's happening. In this case, we are adding these two polynomials. And when we add polynomials, we can only add the terms that are like terms, or that have the same endings. These two are like terms because their variable attached to them is p to the third and p to the third. So I can add those together to get 8p to the third. I mean 10p to the third, because 2 plus 8 is 10. Notice the ending, the p to the third, just comes along. Once I combine the like terms, I usually like to cross them off, so I know that I've actually already combined them, done with that. And also notice that I started with the highest degree or exponent that there were for the terms. Next, well, there's no p squareds or p to the power of 2, so then I guess there's a 5p there. That'd be like 5p to the 1. And there's a negative 1p right here. So when I combine or add 5p plus a negative 1p, I get 4p. And then last but not least are the constants or plain old numbers. I have 1 plus 8, which is 9. Give number 2 a shot. Then after number 2, now notice we are subtracting polynomials, and that makes things a little bit more challenging. In the past, even with just plain old values, we've talked about how it's easier sometimes to add the opposite. We make less mistakes if we organize our work by adding the opposite. Now in this case, we're subtracting off this entire polynomial back here. So if we add the opposite, which I recommend doing, we will have to change the subtraction to adding, and we'll have to take the opposite of everything that was being subtracted. So this positive 4a to the third becomes a negative 4a to the third. And you can go outside the parentheses there. Make sure it's obvious that that's a negative now, because the opposite. Now this is a negative a, but we need to take the opposite of that, so that becomes a positive a. And this 5 was negative, but the opposite of a negative 5 is a positive 5. So now this is just as easy as number 1. Now we're adding polynomials together. Now we combine like terms. If we didn't do that adding the opposite step, it would get to be a little tedious to remember to subtract some value every single time. So now it's just addition. So now I start with the highest exponent I see, and there's a a to the third. There's another a to the third. So now I'm combining 4a to the third plus a negative 4a to the third. So we add the coefficients together, we get 0a to the third, which we actually won't need to write down. That won't be part of our final answer. There's no a to the thirds, so we don't need to write it down, just like there are no a to the seconds. Notice there's no a squareds anywhere. So we move on to the a's. We have 3a and a positive 1a, so that becomes 4a. And we have a negative 4 plus 5. That becomes a positive 1. So that's subtracting polynomials. We just need to remember to add and then take the opposite of the second polynomial, or the polynomial that is being subtracted off. Now we're going to multiply polynomials together. There's no operation here that we see, but remember when we have values or parentheses right next to each other with nothing in between, it is multiplication. So now you can think of this as distribution. We're going to distribute the 4 with the 2n, and that means 4 times 2n. And we're going to distribute the 4 to the 3, which means 4 times 3. So we realize that we're going to get 8n plus 12. But wait, we also need to distribute this n to the 2n and this n to the 3. Now thinking back to our properties of exponents, when we take an n times n, we add the exponents together. So this is going to become n squared. Now there's a 2 that needs to come along for the ride, or in other words, 1 times 2. When I look at the coefficients, 1 times 2 is 2. And then 4 times, just kidding. So we've done n times 2n, and now we need to do n times 3, which is 3n. Then we've added terms together before. These are like terms. That gives us 11n. When we add or combine like terms, we keep the endings the same. So I've combined those now. And then we just need to bring down our 2n squared. That was a positive 11n, so I'll put a plus sign in front of it. If it was negative, I put a minus sign in front of it. And then bring down our constant, 12. So these are like big distribution problems. Let's try one more. Let's do, got any preferences? Let's do this one. So we'll distribute here. We get 5b squared. And we'll distribute here. We get negative 5b. And then here we have negative 2 times 5b. So negative 2 times 5 is negative 10b. And then negative 2 times negative 5 is positive 10. So then we combine like terms. There's a b and there's a b. We have negative 5b plus negative 10b. That's negative 15b. And then we drop down the constant at the end. There's nothing to combine with that. And we drop down the squared term at the beginning. And now this negative 15b, we could just make that into a big old minus sign. Now there's a couple things to look at here. So number 9, you're going to have 6 multiplication rainbows. This 8a needs to get multiplied with everything in the other polynomial, and this negative 6 needs to get multiplied with everything in that polynomial. So you're going to end up having 6 terms here, and you'll be able to combine several of them. Number 10 can get tricky because now if you think about what is 5 squared mean, it means 5 times 5. It means the base times itself. 5 times 5. Now our base here is 5a plus 3. And we need to multiply all of that, so I put that in parentheses, all of that by itself again. And all of that was 5a plus 3. So we need to expand that, folks. In Chapter 8, you learn some shortcuts for using exponents. Those shortcuts don't work here because we have 2 terms in the parentheses. So really we have to expand it, and then you're just doing the same multiplication or foiling to get the right answer there. Same thing in number 11. You'd start out with this 8n minus 2 times 8n minus 2, and now do your big distribution. Alright, moving along to, I'm going to stop that here. We'll talk about factoring here in the next video.